Hi everyone, and welcome to our video on proving some and simplifying a trigonometric expression, or proving an identity there for the second one. All right, so all proving identities or simplifying are really just based on identities from anything that we've dealt with in the past. So reciprocal, Pythagorean. Now we've got all these formulas like addition and subtraction formulas for angles, double angles, and then the half angle. All right, so when we have this, let's write down our half angles to the side. So we have a half angle formula. Let's do the cosine. Let's do u over 2. That's equal to plus or minus the square root of 1 plus cosine of u all over 2. And then we have a sine half angle that looks just the same, plus or minus square root of 1 minus cosine of u over 2. Okay, so there they are. And so when using these style of formulas, notice that this first one, simplify, and we see a big square root. Well, the only formula that we have with trig that has a big square root in it is a half angle. Okay, so that one we can break down pretty fast. So we know this is involving a half angle. No other trig identity has a big old square root in it. And then we look at our 2 and we say, oh, it's this one. It's the sine one. I'm just underlining it. We're going this way to this way though, from right to left. And all we're making sure of is that this u right here is going to be that u right there, which is this angle right here. So that means when we rewrite it, we would have, okay, so, and we can even write it next to it as the 1 minus cosine of u over 2. And on this one, there is no plus and minus, so that means it's automatically the positive. So we can say, well, we're going right to left here on this. This is the sine of u over 2. And then afterwards, again, we're saying that's in the blue is all the same. So we'll change that now to be 16 theta over 2. Okay, so we subbed it in. Let me even keep that in blue. There's the 16 theta and then divided by 2. And then we could say, well, 16 divided by 2 is 8. So this should be sine of 8 theta. That's it. Okay, and we can put the parentheses on it as needed. Okay, so big old square root. It's one of the half angle formulas just in reverse. All right, now verifying an identity. So to verify an identity, we choose a side, and then from there, we try to simplify as far as possible. Well, if there's ever a special angle like there is in this problem, so here we do have a special angle, it's instantly using one of those special angle formulas. Okay, so, or very close to almost instantly, maybe not right away. So for instance, on this problem, we will choose the left-hand side, because we see there's a special angle. And then here's how I'm going to break it down. Well, remember that this secant squared, or any trig function squared, is saying the whole trig function is squared like that, just a rewrite, so a small rewrite. And then I see I have cosine of u over 2 to the side written. Okay, so I'm highlighting this in pink. That's the cosine of u over 2. Well, remember, secant is just is the reciprocal of cosine. So it would say, well, just flip those two around. Okay, so the square root is still there, but we can do our reciprocal. Okay, so the reciprocal is the secant of u over 2. Okay, so if we flip that, so still big parentheses, still squared on the outside, and then we do have plus minus, big square root, and then but 2 in the numerator, and 1 plus cosine of u in the denominator. Okay, well, that square, so this square squares the square root, which will eliminate it, and it will square the plus and minus. Okay, so a positive getting squared is positive, a negative getting squared is still positive. So it works to change this into just pure positive. Okay, so the square root and the square cancel. And then we're saying it's automatically positive. So we're left with 2 over 1 plus cosine of u. And then I look back and say, oops, I started with y. I instantly wrote the one that I highlighted in pink. Well, it's a quick fix, so the letter's different. So sorry. So this should be y. There we go. See how quick a fix it is on this one? There we go. If it was a different letter, you might need to erase it and change it, but on this, it is just the one switch very quickly. Okay, so that was it. So there's our left-hand side. And then I would say that's probably as good as we want to take it. Now let's see our right-hand side, which is 2 secant of y over secant of y plus 1. And then let's use the reciprocal identities on these, where we would have 2, and then 1 over cosine of y, 1 over cosine of y, plus 1. And then we can see, oh, there's a denominator that's the same. It's cosine of y. So we should multiply both the top and bottom of this big fraction by cosine of y. And as we do that, it distributes, or the bottom does. So the top, this cosine, let's highlight it, that cosine of y and that cosine of y cancel. We'd be left with 2 times 1, which is just 2, over this cosine of y does distribute to each term here. And then, well, the cosine of y over cosine of y, let's show it like that, will reduce to be 1. And then we also have 1 times cosine of y is cosine of y. Okay, so the cosine of y over cosine of y, we said does simplify to be 1. And then we can see, oh yeah, they're the same. Left-hand side equals the right-hand side equals left-hand side. So we did verify it. We did prove the identity. Okay, so that's how we break these down. So use those special angles. So notice they can give you the other trig functions with special angles. We usually don't care about them too much because sine and cosine are our main ones. But we can still use sine and cosine to help us. Okay, so that is our half angle. All right, so if you do have questions, please let me know. Otherwise, thanks for watching.